The paradigm to study the gap effect is represented here. It is a relatively short piece of code, less than 100 lines. It is realized in PsychToolbox. If you wish to know more about how it works and also more about the Matlab syntax, I recommend you other videos which have been recorded quite a while ago. I will go through the code to highlight the main elements of it. First, there is a line to initialize the screen, to give it gray color, to remove the cursor from the screen. This is the trigger off, obviously, which is the black square in the left upper corner. Then we wait for 3 seconds. Then we identify all the mat files with the stimuli, which are over there. Fixation, gap, gap left, gap right, overlap left, and overlap right. This has been described in few slides before. So the fixation is the green square in the center. The gap is no stimuli at all, just the gray screen. Then it is stimulus without central fixation and a peripheral target, the red square on the left, on the right, and also on the left and on the right the red square, while the green square stays on the screen, which is called the overlap condition. So we record all those mat files which contain the data matrix to form the textures. We make those 6 textures which will be presented on the screen in the necessary order. So this is a reminder, just a comment, which are the textures. Then we generate 4 experimental conditions. The number of those conditions correspond to the numbers of the textures, which is pretty convenient. So this is an array filled with elements of 3, 4, 5, and 6. Those are the values. 20 presentations for each. In total, it will be 80 conditions. And then we randomize those conditions and we store all of them, the sequence of the conditions, in the result variable. And now this is the beginning and this is the end of the main experimental loop, which will repeat the trials. So at the beginning there is always a fixation, central green square. The trigger is off, a black square in the corner, and we flip so that the image goes on the screen. Then we wait for 3 seconds and a jitter of 3 maximum and 0 minimum. Therefore, the fixation lasts from 3 to 6 seconds randomly. And for each trial, the condition is identified. If it's less than 5, it is gap. Not less than 5, it is overlap, right or left. So if it is less than 5, then a gap condition is introduced, which is lack of any stimulus. And the trigger is still off. So it is a black screen, a black square in the corner of the screen. Otherwise, it is texture 1, which is still the fixation for the overlap. We are prepared for the stimulus, but the stimulus is still not there. It is sort of pre-stimulus condition, which is the fact that for the gap, the central fixation disappears for a brief interval of 200 milliseconds. Then, as a function of the condition, we draw the texture with a target. So it will be either left or right red square, the target for the saccade, and also the cue for left or right hand response as a function of where the stimulus is. And immediately, well, at the same instance, we prepare the black screen, but also the white screen in the center of black square in the corner of the screen, which will be the trigger for synchronization of our electrophysiology and the actimetry with the experimental condition, with the stimulus shown on the screen. And when we flip, the two of them, the target and the trigger, the white square in the corner, appear almost at the same time on the screen. Obviously, the top of the screen is refreshed earlier than the middle of the screen, but this delay is standard and therefore can be sorted out of our measurements. Therefore, then there is a delay of 2 frames, which is about 30 milliseconds. And then we keep the texture of the target the same. It is just the same as before. But what we do at after this short delay, we remove the trigger, so that there is a very short response in our lux matter channel, which is easy to identify as the onset of our target presentation. And then we flip again, and that's it. We wait for a second of the target presentation, which is more than enough to respond. And then we go to the beginning of the loop, where the fixation in the center, just the green square in the center, is shown. And at the end of the script, we we save the results. Well, the results are basically the conditions, the order of the conditions, which is very important. And also the timing of the conditions, which is also very important. VBL timestamp, this is the time measured by the screen function. Add the time of the refreshment of the screen when the trigger and the stimulus, the target, are shown. So we store the time of the presentation and we store the order of the conditions. Those are two things which are important. And then there is a catch part of the try loop, which is not used a lot when everything goes well, but if there is an error inside the try part, the Matlab goes directly to the catch part and it shuts down the screen function so that we can figure out what is wrong. Otherwise, there is a risk to have the screen turned off and disabled for a long time without much possibility to shut it down.